Section 3. Number 1, cosine to the fourth x minus sine to the fourth x is a difference of squares that factors like this. The cosine squared x plus the sine squared x is equal to 1, so that cancels. And this part is the trig identity for the double angle of cosine. It's one way to write that. So we just need this one step, and we have proven number 1. Okay, looking at number 2. First thing you should think when you see number 2 is that you need to FOIL. So tangent squared times cosine squared. Remember, tangent is sine squared over cosine squared. So I'll write it like that. So I've got sine squared times sine squared over cosine squared times the cosine squared plus cosine squared minus 1 minus the tangent squared. And it lets me write it. Okay, simplifying, sine squared over cosine squared times the cosine squared of x is just equal to the sine squared. The cosines cancel. Then we've got plus cosine squared minus 1 minus the tangent squared of x. Well, over here, didn't we say that the cosine squared plus the sine squared is equal to 1? So it must still be equal to 1 here. So that gives us 1 minus 1 minus the tangent squared. Well, 1 minus 1 is 0, so we're left with negative tangent squared of x, which is what we were trying to prove. Okay, number 3. We solved a lot of problems like number 3. First thing that we need to do on number 3, it doesn't really matter what side we choose. I'm just going to choose the left side, and I'm going to multiply the left side by 1 plus the cosine of beta over 1 plus the cosine of beta. I'm doing that so that I will get a difference of squares. This symbol beta is just a different symbol for an angle. 1 minus the cosine of beta. Okay, so when I distribute in the numerator, I get the sine of beta plus, well, actually, we'll leave it as 1 plus cosine of beta. We don't need to distribute, just leave it like that. Divided by, when I FOIL the denominator, that's a difference of squares because I wanted it to be a difference of squares. 1 minus cosine squared of beta. Okay, over here. So my numerator, I'm not going to mess with my numerator. Sine. Beta times 1 plus the cosine of beta. My denominator, 1 minus the cosine of beta, is equal to the sine squared of beta with my Pythagorean identity. So I can cancel now 1 sine in the numerator with 1 sine in the denominator, and that leaves me with 1 plus the cosine of beta divided by the sine of beta, which is what I needed. Okay, number 4. I saw a lot of you do this problem very differently, so let me just present to you one way that people solve this. Secant squared x minus 1 is equal to the tangent squared of x with one of our Pythagorean identities. So I'm just going to substitute in tangent squared of x over secant of x secant squared of x, excuse me. Well, let's write these in sines and cosines. This is the sine squared of x over the cosine squared of x divided by 1 over the cosine squared of x. Okay. Well, remember we're dividing by this. We need to flip and multiply. When we do that, our cosines are going to cancel, and we'll get the sine squared of x. Okay, section 5. For the number 1, you need to figure out two angles in radians that add up to 112. A couple different ways you can do that. You probably need to use subtraction, first of all. Let's think of it this way. How can you get 112? Well, you can get 112 by taking 4/12 and subtracting 3/12 from it. That gives me 112. 1/6 plus 1/6 is not 112, although a lot of you wanted it to be on your test. Well, 4/12 reduces to 1/3, and 3/12 reduces to 1/4. So let's write the sine of pi over 12 as the sine of pi over 3 minus pi over 4. So if we do that and then apply the angle difference formula, we get the sine of pi over 3 times the cosine of pi over 4 minus the cosine of pi over 3 times the sine of pi over 4. And this is knowing our unit circle. The sine of pi over 3 is radical 3 over 2. Cosine of pi over 4 is radical 2 over 2. Subtracting cosine of pi over 3 is 1/2. Sine of pi over 4 is radical 2 over 2. And when we simplify that, we get radical 6 minus radical 2 over 4. Looking at number 2 over here, cosine of 75 degrees, let's use 30 degrees and 45 degrees. So cosine of 30 plus 45 degrees. So we get cosine of A, cosine of 30, times the cosine of 45. Since we have plus here, this is minus the sine of 30 times the sine of 45. And then we plug in from here. Cosine of 30 is radical 3 over 2. Cosine of 45 is radical 2 over 2. Minus the sine of 30 is 1/2. And the sine of 45 is radical 2 over 2. And again, simplifying, we're going to get the same thing we got number 1 over here, radical 6 minus radical 2 over 4.